All right, this is 8.3, which is the more graphing, but you have to talk about the discontinuities and vertical asymptotes and horizontal asymptotes, how they're created. So this is the bigger section. It's not just the simple shifting of H and K anymore. Okay, so discontinuities happen when you divide by 0. So you set the denominator equal to 0. Well, it's already factored here. So it's a piece of cake. X cannot be 4 and X cannot be -3. Interestingly enough, there's two kinds of discontinuities. When it's the same thing divided by the same thing, this discontinuity is a whole. And when it's this one here, this discontinuity is a vertical asymptote. All right, but there are two discontinuities. There's just one of each. Over here, I factor, or just think about this. It's not that big a deal. It's x is equal to plus or minus 2. Those are the places that it cannot be, because those would cause you to divide by 0. But the same thing happens here. It's x plus 2, x minus 2, and then it's over x minus 2. So that creates the whole, and then so 2 would be the whole, and then the other one is the vertical asymptote, the -2. All right, so there's the answers for those. The horizontal asymptotes are created by when x becomes really super large. So remember, we look at this and we look at the exponents. This is an exponent of x to the 0 power versus x to the first power. So when it's smaller over larger, it's always y equals 0. And that's because x is becoming so large that you're dividing a huge number into 2, so it just basically goes to nothing. When it's a tie, we use the coefficients, so it's 1 and 1, so it's just 1. And here it again, it's smaller over larger, so that'd be y equals 0. And then here it's large over smaller, so it's the opposite. There is none. There's no horizontal asymptote. All right, now we're going to make the graphs. I'm going to make a couple of graphs here and try and put as much detail in it as we can manage here. It's factored for us, so that's nice. So first of all, there's no x up here versus x squared. So that's a horizontal asymptote of 0. So y equals 0 is the boundary here. And let me get a highlighter out. So this would be the horizontal boundary. Okay, so it doesn't cross that. Then there's two vertical boundaries. There's one at 2 and -2, right? There's no holes or anything. So here's -2. And here's 2. Okay, so these are the boundaries this way. I missed. All right. Now we just need to figure out, does it cross the x-axis? Well, it doesn't. There is no x-intercept, because when you set the top of the equation equal to 0, there's no answer for that. So setting the top of the equation equal to 0 gives you your x-intercept. Setting the bottom equal to 0 gives you your asymptotes, your vertical ones. Okay, so this would give you your x-intercepts when you set the top of the equation equal to 0. When you set the bottom of the equation equal to 0, that's your vertical asymptotes. And there's two of those, but there's no x-intercept. Now we're going to find the y-intercept by putting 0 into the equation. So I'm going to put 0 into the equation here, and that would give me 3 on the top, and it would give me -4 on the bottom, so -3/4. So 0, -3/4 is my first point that I can put in here. Now I have to figure out, does it do this upside down thing, or does it kind of curve through in an S shape? Well, I'm going to put 1 in and then figure out what it does. So put 1 in. When I put 1 in, I get 3 on the top, and it turns out I get -3 on the bottom, which would be -1. So it's 1, -1. And then I'm going to put in -1, and I still get the same thing. I get 3 on the top, and I get -3 on the bottom. So it's -1, -1. So this right in here is an upside down parabola-like shape. It's not a parabola, but it looks kind of like one. Now we have to figure out in this quadrant, does it curve like this, or does it curve like this, or how does it curve over here? Well, try a point. So 2, I'm going to go to the next point over, I'm going to go to 3. So I'm going to put 3 in for x. So 3 goes in, and I get 3 on the top, and I would get 1, now I get 5 times 1, I get 5, so it's 3/5. And then if I put in -3, I also get 3/5. So it's 3 over and up a little bit, and -3 over and up a little bit. So it curves right like this and like this. All right, so there's my graph for that. So there's a vertical, 2 vertical asymptotes, 1 horizontal asymptote. I just tested points and figured out that it curved like this, like this. And then you're more than welcome to type it into your graphing calculator and see that it matches this. But if you don't understand that these boundaries are here, it doesn't make any sense on your graphing calculator. So that's kind of the purpose of doing this. Okay. So 1 over 1, because this is a tie, then it's going to be a horizontal asymptote at 1. Okay, and then the bottom set equal to 0 would be plus or minus 2, so it's plus or minus 2 like the last one. All right, and I'm going to find a better highlighter. Here's the orange one. So it's going to be like so, and like so. So those are the boundaries. Okay. So like I said up here, setting the top equal to 0 gives you your x-intercept, and there wasn't one because 3 equals 0 doesn't make any sense. Setting the bottom equal to 0 creates your vertical asymptotes. So I did that. Okay, plus and minus 1. So 1 would give me 0, because if I put 1 up here, then that would make the whole fraction 0, and then -1 would also make the fraction 0. And then I'm going to put 0 into the fraction. Well, if I put 0 into the fraction, I get -1 on the top and -4 on the bottom, so I get 1/4. So that means I have all these points right here done. 1, 0 is here, -1, 0 is here, and 0, 1/4 is right there. So now we know that it curves, it can't go past these, so it does this parabola-like thing here in the middle again. All right, then I just need to test other points to see if it curves here, or there, or there. So this is 1, 2, so I'm going to try 3 again. So I'm going to put 3 in for x, and that's going to give me 8 on the top, and 5 on the bottom. So that's kind of ish close to 2. So I go over 3, and I go ish up. There's 1 right there, so it's going to curve like so in this area. And then put in -3, and I also get 8/5. So it's going to be curving in this area. Boom, boom. There's the answer.